Dear friends, our question is prove that tan of a plus b plus tan of a minus b is equal to sin 2a minus cos square a. This is one of the most important questions that is frequently asked in various exams. Now let's check how to solve this. We've written the LHS tan A plus B plus tan of A minus B. Now let's use the compound angle formula of tan A plus B, tan A minus B. We have now written the compound angle of tan A plus B plus tan of A minus B that you can see on the screen. I have written the compound angle formula of tan. Now we are going to simplify taking LCM of these denominators. With the simplification of taking denominator as LCM, now we have these terms. We have these terms that tan A plus B multiply with this term and tan A minus B multiplied with this term and all upon the denominators, product of these denominators. Now we are going to multiply these two terms and multiply these two terms, and let's check what we get. After multiplication we get this term, and from here now we are going to cancel the like terms with the opposite signs. After cancellation we just check the denominator, and in the denominator now here we can see 1 minus tan A tan B, 1 plus tan A tan B. So if I consider 1 as x and tan A tan B as y, then I get x square minus y square. So here I have written 1 square minus tan A tan B whole square. Now we just go and find what is the resultant term, and now we have these resultant terms. From here what we are going to do now is we are going to change tan as cos upon, we are going to change tan as sin upon cos. After changing tan in terms of sin and cos, I get these terms. Now I am going to simplify these terms again. After simplification, we get this term 2 sin A cos square b plus 2 sin A sin square b upon cos square A cos square b, and the total upon cos square A cos square b minus sin square A sin square b upon cos square A cos square b. Now let's go and simplify this again. Let's change these division into forms of multiplication. After changing this division in terms of multiplication, we get this term. Now here we can cancel cos square b with cos square b, and this cos A cancels the square of this cos square A. Now cos A is remaining here, and this will multiply this total term. This will multiply this total term, and in the denominator we have cos square b minus sin square A sin square b. Dear friends, from here I am going to change this sin square A in terms of cos square A in the next step. Now after taking common from the numerator, we get 2 sin A cos A times cos square b plus sin square b, and changing sin square A of the denominator in cos square A, we get cos square A cos square b minus 1 minus cos square A times sin square b, and in the later step let's multiply these two terms and check what happens. And this one here now you can see cos square b plus sin square b is sin square theta plus cos square theta, which is equal to 1. And now I have 2 sin A cos A times 1 cos square A cos square b minus sin square b and minus cos square A sin square b. Now in the next step I write these two terms together and take common. Here you can see that this whole thing multiplied by 1 is the same, and now we wrote these two terms together here. Now let's take cos square A common, and this one 2 sin A cos A is equal to sin 2A. Now here after taking common you can see that I get sin 2A in the numerator, and denominator I have cos square A times cos square B plus sin square B minus sin square B. Here we can check in this bracket, this term is going to be 1 as we have sin square theta plus cos square theta. Now here you can check that this whole thing is going to be 1, so I get cos square A times 1 minus sin square B. So dear friends, now our problem is solved. Here I get sin 2A upon this one multiplying, I get cos square A minus sin square B, which I needed to prove in the right hand side. So this is proved. Thanks for watching. If you like my video, do not forget to subscribe my channel and press the bell icon, as well as you can share this video